Okay, hi everyone, welcome back to my channel. Today, we're going to be diving into the fascinating world of databases. Especially, I'll walk you through the design of a healthcare database, explain its structure using an entity relationship diagram, or what we can call an ERD, and then review the SQL code to implement it. By the end of this video, you will have a solid understanding of how to design and implement relational databases for a real-world scenario. Let's start with an ER diagram, which visually represents the relationship between entities in our healthcare database. Right now on our screen, we have our ER diagram, of which it has entities like geographical location, healthcare facility, malaria cases, patient data, treatment outcome, and treatment. And starting with geographical location, this entity represents where healthcare services are provided. And it has attributes which include location ID, which is also a primary key, and other essential areas like essential attributes like population, parish, sub-county, reported cases, and many more. This is essential for identifying regions with specific healthcare needs. And in case you're wondering why this village is in a double oval shape, it is because a village is what we call a multi-value attribute. This is whereby a village, one geographical location, can have multiple villages. So that is why we put it in a double oval shape. Then we have a health facility, which represents hospitals, clinics, or other facilities. And the primary key in a facility, the primary key in a health facility is a facility ID, and it has a foreign key linking to a geographical location. It is linking to a geographical location, and it linking to the geographical location entity via the location ID. This connection helps to identify which facilities operate in specific areas. Next, we have the patient data entity. And our patient's data entity stores personal and contact information of patients. And it has attributes like patient's ID, the date updated, the first name, last names of the patients, and along with the details like name, birthday, and also the address. Then we have another entity called the treatment and the treatment outcome. The treatment entity stores details about different medical treatments, while the treatment outcome entity stores records and results for those treatments. And these both entities are linked to a malaria case entity via foreign keys. Then we also have a malaria case entity, which also has attributes like case ID, which is a unique identifier, or the unique identifier, or what we can call a primary key, and also some other attributes. Then the relationship between a geographical location and a health facility is one to many, in that many health facilities can be in one geographical location, hence making it a one-to-many relationship. And this diamond shape shows that the geographical location has the health facility. Then also the health facility treats the malaria case. So one health facility can treat multiple malaria cases, making it a one-to-many relationship. Also, the malaria cases, a malaria case belongs to the patient. Yeah, a malaria case belongs to a patient. Hence, a patient, many malaria cases can belong to one patient. Then we have also another relationship here, whereby a malaria case has a treatment outcome, because when someone is sick, there can be that kind of relationship after they have been treated. So malaria case has a treatment outcome, and very many malaria cases can have one treatment outcome, or one treatment outcome can have very many. One malaria case can have very many treatment outcomes, making it a one-to-many relationship. Then we have another entity, treatment, which has a relationship with the malaria case, in that one treatment, there can be one treatment for multiple malaria cases, making it one-to-many relationship. Yeah, then lastly, we have this kind of relationship whereby a treatment leads to a treatment outcome. Hence, one treatment can have many treatment outcomes. Someone can be treated and they can be healed, and some other people can be treated and they cannot be healed, and all those are outcomes. So, one treatment can have very many treatment outcomes. And this ERD helps us to understand the relationships between these entities in a structured way, making it easier to translate into a relational database using a SQL. Now that we have covered the ERR diagram, let's take a close look at the SQL code that implements this database. I'll walk you through each table, highlighting key features. So if I can pull up my database, this is my SQL code over here. And the first line of code here, we can see the comment here, we create a database if that database does not exist yet. So it says create database if that database does not exist yet, and the name of our database is going to be called healthcare DB. Then the next line of code is going to enable us to use that database that we have created. Hence, all these tables that we are going to create are going to be inserted inside our database that we just created. Hence, here we shall be using this database. Then we start on the tables. The first table shows the geographical location. Here we create a table for the geographical location. And if you can notice, I have the location ID, which is the primary key, and other fields like the village, parish, and the population are defined with appropriate data types, such as variable characters, which is of size 100. Then also integer, we have decimal and other data types inside here. The next table, we have the patient's data. In the patient's data, we have a patient's ID, which is a unique identifier also in this case. And the table is straightforward with fields like first name, last name, date of birth, and the primary key is patient's data, which uniquely identifies each patient. The next table, we have a facility, health facility, of which the health facility, it includes a foreign key to our location ID. And that location ID, it is referring the location table, and this ensures that each facility is tied to a valid geographical location. Hence, we shall have that foreign key of location ID referring it to a geographical location table, and it will be referring directly to the location ID inside our location table. Then next we have the treatment table, and of which the treatment table will hold the treatment ID, which is also a primary key to uniquely identify each treatment for a patient, then the treatment name, all with corresponding data types. Then next we have the treatment outcome, and also it is going to be having a primary key, which is going to be of a type integer. Then we have the date updated, which is going to be of a type date, because it's going to hold the date and the same as date added. This variable character, it means that we can actually have a character or a number. Yeah. Then we have what we call the Morelia cases. Now, the Morelia cases table, this table is where the magic happens, and it ties multiple entities together using foreign keys. For example, the patient ID links to the patient data through the patient ID. Hence, it's going to be a foreign key linking to the patient's data and bringing it to the patient ID. We also have the facility ID that links to the health facility, and also the treatment ID that links to the treatment. Yeah, links to the treatment table, and also the outcome ID that links to the treatment outcome. And over here, we have the summary or the sample data that I just inserted, just to make sure this one works very fine. And yeah, so notice the use of on delete cascade, this one that I was using here, on delete cascade, and on delete set. I somewhere used on delete set, which is here, on delete set and on delete cascade. In the foreign key constraints, They ensure that changes in the parent tables automatically propagates to dependent tables, and this helps to reduce the risk of orphaned records or neglected records that are not so helpful to the user. And to recap what we actually looked about, we started with an ER diagram that visually represents the relationship between entities. Then we translated into design we translated that design into the SQL code to create a robust, scalable healthcare database. And this process is essential for managing complex data systems efficiently. If you found this video helpful, please give it a thumbs up and subscribe for more database and programming tutorials. And if you have any questions or suggestions for a future topic, drop them in the comments below. Thanks for watching. Happy coding.